Okay, so for 31, it says decide whether you have enough information to prove that those two triangles are congruent. It shows that you have this side equal to this side, and it shows that this angle is equal to this one. So you're looking for one of these, and to be honest, I know it might be hard to remember all four of those, but it's literally every combination you could have except for ASS, and remember, if you get a cuss word, that isn't one. So something that comes up a lot is a shared side is equal to itself. So here you have angle side side, which is ASS, which isn't a congruent statement. So no, you don't have enough information to prove that they're congruent. They could be, but you don't have enough info. Not enough info. Okay, for 32, that is what we did yesterday. You're trying to determine if they are similar. If they have all their angles the same measure, then they would be similar. So right here they have one angle in common. You're trying to see if they have another angle in common, technically all three. 180 minus 105 minus 28 comes out to 47. So this would be 47, and then you have two angles in common with two angles over here. This third angle, if you were to calculate it, would be 105. All the angles are equal, so yes, they are similar. And then as far as the similarity statement goes, when you make the similarity statement, you have to go in the same order for the angles each time. So HIG. And when I write this second one, I went from 105 to 47 to 28. So I'm going to go NMO, same order, like that. Okay, and then for 33, for 33 shows a stop sign, which is an octagon and 8-sided shape. Find the measure of each interior angle and each exterior angle. So to find the sum of all the interior angles, we can use the equation n minus 2 times 180. That equation is not on the reference sheet, so that's something that you'd have to memorize. Luckily, it's a pretty easy one to memorize. 8 minus 2 times 180 would be 6 times 180, which comes out to 1080. Now that number is all of the angles added up, and it wants to know each interior angle. So once you get that total, you do have to divide it by 8 to get each one, which comes out to 135 degrees for each one. So each interior angle is 135. Then for the second part of the problem, it wants to know the exterior angles. Each exterior. For any polygon, the exterior angles add up to 360. So do 360 divided by 8, and it comes out to 45 degrees for each exterior angle. Find the measure of angle S right here. You're shown a kite. In a kite, this angle is the same measure as this one, so that is important to know. Also, for a quadrilateral, the angles add up to 360. So for a quad, adds up to 360 degrees. So we can subtract these two angles and then divide whatever we have left by 2 to get each of those. So 360 minus 42 minus 64, we get 254. And then divide that by 2 to get each of those, which comes out to 127. So measure of angle S, 127. And this would also be 127 as well. Okay, I challenged some of the higher level students to try number 35. It says the area of ABCD is 288 square meters, 288 meters squared, that's the whole area. Find the area of this right here. Well, notice that we only have one dimension here and here. So let's try to figure out this dimension here. To find the area of this, it would be length times width, right? So area equals length times width. We're told the area is 288, the length is 24, and we'll call this the width. We don't know. So here to find that length, I can just divide by 24. Width would be 12. So 288 divided by 24 is 12. So that's this length right here. Now in order to find the area of this, I need to find the width right here. I'm told that they're similar. So I noticed that 24 divided by 4 is 6. 24 divided by 4 is 6. So 12 divided by 4 would equal 3. And then to find the area of this, I can just do length times width, 6 times 3. So the area is 18 meters squared. Did anybody try number 36 or no? I didn't get that. You did try it? If you did try it, it's a rectangle. Did you get rectangle? Okay. I'm gonna stop recording.